There are thousands upon thousands of chemicals entering into the Great Lakes watersheds. They're forming mixtures, they're causing antagonistic or additive impacts. So you can imagine that to develop the standards necessary for the chemical analysis and also just the testing itself is incredibly slow, requires extraordinarily specific expertise, and is very expensive. But what we've started to do is ask aquatic organisms that are indigenous to the Great Lakes if they're stressed by contaminants impacting their environment. So the way we do that is, first of all, within the lab, we study their ecological behaviors under reference conditions. Once we've reached that stage, we then add the stressor, the contaminant, and we watch their behaviors at that point and record what stress behaviors will be. The advantages of using living entities to show stress is it's incredibly environmentally rigorous, environmentally relevant, scientific, but it's relatively cost-effective and it's in real time. We have a genus species called Daphnia magna, and they exist in the water column. So they swim through the water column with saltatory swimming behaviors. Their common name is actually water flea. Now, these saltatory swimming behaviors under normal conditions are to get away from predators, avoid being eaten is actually your first mandate, and then filter feeding the algae in the water, which is their food source. Once we have a feeling for their swimming behaviors throughout the water column under normal conditions, we can then add a contaminant. A contaminant that we're really interested in, for example, tributyl tin. It is sprayed on the hulls of the Lakers and the international cargo ships that pass through the Great Lakes. We add this tributyl tin to the Daphnia and we watch its swimming behaviors. And often under stress conditions, the Daphnia fall through the water column, they've lost their equilibrium, often mobility is totally compromised. They go into swimming and destructive spiraling behaviors. And so from there, then we can get a feeling of what stress responses look like in these organisms. But what, of course, has become very established as our students have gone through is that we do have communities with terrifically marginalized drinking water in Canada. And that, of course, is First Nations. And that took us a long time to really focus on. And now one area of our work is working with First Nations and asking them, would they like a miner's canary just upstream of their drinking water intake pipes that could tell them very quickly if a stressor was coming through and to shut down their drinking water intake pipes. I think Ryerson is still such a maverick institution of being able to look at the world a little bit differently than some of the more established universities around. So I think because of its applied history, this idea of many expertises coming together, many disciplines to figure out problems is the only way to go forward as far as environmental problems anyway. And Ryerson really supports the evolution or the continuing development of multidisciplinary expertises coming together.